The next topic we're going to talk about are the two types of terrestrial water. The first is surface water, and this is as it sounds, waters that are on the surface. These are lakes, streams, and the oceans. The second type is what's called groundwater, and groundwater is the water that's penetrated the ground and is held within pore spaces and cracks and crevices within the layers of the earth. Now, the groundwater gets there through a process called infiltration, which is just when the rain or the water comes down, it goes and it migrates down through the pore spaces and the cracks in the rocks. The first place that it goes through as it moves in is what's called the zone of aeration. And the zone of aeration is in the topsoil and the subsoil, and it's where you have the pore spaces that have the water and the air moving through them. And the water here is called capillary water. Now, some of this capillary water is absorbed into roots plants. Other is used to help biological life in that zone. And as the water comes down through this zone, we talked about if there are pollutants in the water, some of those pollutants will actually stick to the grain surfaces down there, and the grain surfaces will actually purify the water as it moves deeper into the ground. Beneath this zone is called the zone of saturation. So if I have an impermeable layer here of clay and the water can't go down through it, I have the water coming down, it hits the surface, eventually it will come down, and if it's a porous layer, it won't be able to go any further down than that. And within this body of water, the top of it is what you call the water table. Now, the water table may not be at the top of your porous layer. If you have a time when you're in drought, a long period of drought, the water table will actually lower. So that's less available water. And if you're a time where there's plenty of rain, the water table may actually be higher, so there's more water to be withdrawn from the ground. Now, excuse me, these layers are called aquifers, and aquifers are important because this is where we get most of our water from. Our drinking water, our water for irrigation, our water for operations in production plants. So looking at the aquifer, how much water is in there and how we can protect that water is vitally important. There are two types of aquifers. The first one is called a fossil aquifer, and what happens is millions of years ago, you have a layer and you'll have sand being deposited on top of it, and it has water in it. Well, eventually over time, the system changes there, and you have more clays that will come and will be deposited on top of it. So you have this layer with water in it sandwiched in between two impermeable layers. Well, over time, more sediment comes on top of it, and it puts pressure on it. So you're actually squeezing the aquifer. Well, if you come and you drill into this aquifer, because it's over pressure, whenever you drill into the top of it and you go through the top layer, the water will start to come out. Now, fossil aquifers have a property that fossil means paleo water or old water. Because you're between two impermeable layers, when the rains come down, they can't recharge this aquifer. So once you've withdrawn the water from the aquifer, it's dry and it's not a source of water anymore. In countries where it's arid, like Saudi Arabia and other countries in the Middle East, they have not surface aquifers or rechargeable aquifers. Because it's so arid, so they have to drill deeper into these fossil aquifers. Well, they used a lot of this water for irrigation, and when the fossil aquifer dried up, they were out of water. Right now they have desalination plants, so they take the seawater and they take the salt out of it, and that is what is used now for 70% of their all the water used in Saudi Arabia. Because they don't have a large water supply, though, they have stopped producing a lot of their own crops, and they're now importing 90% of their wheat. So now they're dependent on the rest of the world for their supply of grains. And we're going to look at the interactions between soils in different places, water supplies here, and how you can't just, you have to look at this as a world system between pollution and economic dependence. We talked about less developed countries, more developed countries. All of these things are really integrated, and hopefully as we move through the course we'll be able to make more of these connections and be able to look at the biosphere as a whole, and hopefully be able to see some ways that we can actually stop these negative processes and revitalize the positive processes. Okay, so that's a fossil aquifer. The other type of aquifer is what's called an unconfined or a rechargeable aquifer. And this is one where the surface waters can come down and they can actually recharge the aquifer. Now, one of the major aquifers in the United States is called the Ogallala Aquifer, and it extends from Texas up through the high plains to Nebraska and Kansas. And this is a large area where we have agricultural production for the country. This aquifer, because it's in an arid region, only receives about 1 inch of rain a year to recharge it. And right now, with the amount of water that we're pulling out of it, we're using 50 times the amount of water that can be recharged in 1 year. So this is being seriously overdrafted, and overdrafted just means that you're removing more water than can be naturally replenished. And most of the aquifers in the world, most of the water sources that people use around the world are from rechargeable aquifers. So if we have an area where we're drawing too much water and it's not going to be able to be replenished in our lifetime, this is a situation where it has to be addressed now. It's critical at this point that we find ways to use less water, that we find ways to make sure that our water supply is not polluted. Some of these aquifers, in the Ogallala is an example, the top of the aquifer may only be 50 feet below the surface, and that's not enough time for some pollutants as the water infiltrates through the ground to remove all of the pollution from it. So these systems that we're looking at, and particularly the aquifer system that we are relying on, it is one of the critical factors we need to look at. And as a matter of fact, NASA did a study and they found that over half of the world's large aquifer systems are stressed or overstressed, which means that they could the Ogallala is one of them, and actually if we continue at our current rate of consumption, it could be run dry by the end of the century. So those are the water sources. This is why it's important for us to be able to look at things from watersheds to pollutions to how it affects large areas of the ecosystem, to underground waters, air pollution. All of these things we're going to see tie into one bigger picture. So I hope this was instructive, and it's going to be a great week. If you have any questions, email me and I'll get back to you. Thanks for listening.